explosion is an explosion of biodiversity that happened about 542 million years ago following a mass extinction at the end of the Ediacaran period. During the Cambrian explosion, many species are thought to have appeared with distinct traits such as teeth and exoskeletons. New ways of life also appeared that had not been observed before. One example of this is Otoya, a species of worm that burrowed in the ocean sediment. There was another biodiversity explosion called the Avalon Explosion about 33 million years before the Cambrian explosion took place. The Avalon Explosion was not as large, but definitely deserves some notice. It is very important to study these biodiversity explosions so that we can better understand how and why we have as many species of organisms as we do today. No one is 100% certain as to why the explosion happened, but there are a few widely accepted hypotheses.
The first hypothesis is that the warming environment at the end of snowball Earth caused cool water to rise due to all of the glaciers melting. This hypothesis also states that phosphate levels may have increased as the glaciers melted as well.
The next hypothesis is that the rising of cool waters killed off much of the oxygen-consuming bacteria in marine ecosystems. This would increase the availability of oxygen levels for the development of biodiversity, since oxygen was essential for many metazoans to maintain many metabolic and physiological processes.
The same upwelling of cool water which may have caused oxygen-consuming bacteria to go extinct may have been responsible for the development of a wide range of ecological niches. A great variety of depths and temperatures became evident in marine ecosystems during the time of the Cambrian explosion, but we will come back to this idea shortly.
Another explanation for the adaptive radiation and extensive speciation during the Cambrian explosion is the new presence of a predator-prey environment. This new selective environment increased the selective pressures on organisms. No one is entirely sure of the exact interactions. However, this example is parsimonious. The new predator-prey interaction likely caused selection for various traits that would allow the organisms to escape from predator or to protect themselves when predators want to eat them as their next meal.
As time continued, these organisms with varying traits would experience selective pressures, tying back into the hypothesis regarding ecological niches as a tool for speciation.
New research is suggesting that a sudden surge of calcium in oceans caused by volcanically active mid-ocean ridges made it possible for marine organisms to develop exoskeletons and hard parts. An example of this development is the extinct species Wiwaxia.
Wiwaxia was a species that lived on the bottom of the ocean during the time of the Cambrian explosion. Wiwaxia also happens to be a close relative of a key species in tetrapod development called Tiktaalik. Wiwaxia had hard parts in the form of spiky scales on the dorsal part of its body and a very soft underside. This hard shell morphology would have potentially provided structural protection from predators in the evolving predator-prey environment.
This brings us to the end of today's topic, so just to do a quick recap.
We discussed some of the events before the Cambrian explosion which may be able to explain the extensive adaptive radiation.
We discussed the development of ecological niches and why these were important for speciation.
Finally, we discussed the evolution of a predator-prey environment and its influences on selective pressures.